Every ellipse has a center, and the center is the midpoint of either the major or the minor axis. In this case, the center is at 0, 0. But what an ellipse also has are 2 points that are known as the foci of the ellipse. And what the foci are 2 points, 2 special points in an ellipse that have a special property that if I take a point on the ellipse and I were to add together the length of the line segment from one focus to that point and from the other focus to that point, it would equal the same thing for every point on the ellipse. Now, a couple of things about these foci. The foci are the same distance from the center, and that distance is called c. And I'm going to show you how we can calculate out that distance. Here's an ellipse that has a major axis of 10. Now, if this and this together is equal to the same thing as this and this together, and so on, it will also be true if the point I pick is not here or here, but is one of the vertices. So I'll call this F1, F2, and this is P. And I want to show to you that F1P plus F2P in this case must equal 10. And here's why. F1P is this line segment. F2P is this line segment. But because of like symmetry, F1P is also equal to this line down here. Maybe I'll call that F2Q. But together, those things make up the entire major axis of the ellipse. So it turns out that in general, the magic number is 2a. That's the magic distance. If I take any point on the ellipse, that means if I take this point and I add this line to this one lengths, I'll get 10. Or if I do it for these two, I'll get 10. Or if I do it for these two, I'll always get 10. This is going to help me find the distance from the center to each focus, which I'll call C. You see, if 10 is the magic number for this ellipse, it's true for any point, including the point right here, the endpoint of the minor axis. Remember, this is called B, which in this ellipse, the x squared minus 9 plus y squared over 25 equals 1. It's 3 in that case. Now, if 10 is the magic number, and if I draw from here to here, these two things combined will be 10. But because of the way this thing's located, these are actually equal to each other, which means they're both 5 and 5. They're both 5. And in general, the line segment connecting the focus, either focus, to the endpoint of the minor axis will be equal to the value that's called A. It means that this length here, this blue, is the same as this length here, which is kind of surprising. But it also means that we have a right triangle. This green right triangle right here, if I bring it out, has C, the thing I don't know, has B and A in it. In this case, 3 and 5. So using the Pythagorean Theorem, C is 4, which means these foci in that ellipse we've been having are actually located at 0, 4, and 0, negative 4. In general, the relationship is that C squared is equal to A squared minus B squared. It's like the Pythagorean Theorem, but it's got a minus instead of a plus, and that's because the hypotenuse is the A in this case. Remember from a different lesson that the eccentricity is the square root of A squared minus B squared over A. Well, that means that it's also C over A, because C squared is A squared minus B squared. So we have these two properties. One is that C squared equals A squared minus B squared, and the other one is that E equals C over A. And if I know any of these two of these things, I can find the other two. So in this case, I have an ellipse that has major axis of length 8, minor axis of length 6. Now, I didn't say this already, but the foci are always on the major axis, so they're going to be like somewhere over here and over here. But where exactly? Well, c squared is a squared minus b squared. This is actually a squared, and this thing is b squared. So c squared equals 7, or c equals the square root of 7, which is a little bigger than 2. And the coordinates of the foci in this case are root 7, comma 0, and negative root 7, comma 0. Here's a situation where I know the two foci and the two endpoints of the major axis. So a is 10 and c is 8, and I could use that to calculate out b. C squared equals a squared minus b squared. 64 equals 100 minus b squared, or b squared equals 36. So my equation is 136 here. Now here are two pretty complicated questions. What if I told you the eccentricity of an ellipse is 5 over 13, and I told you that the foci were at 10, 0, and minus 10, 0? I'll draw a little picture to get a feel for this. So I want to show you how we can get the equation of that. If c is equal to 10, because that's the distance from the center to the foci. So c over a is equal to 5 over 13, but c is 10, so 10 over a is equal to 5 over 13, which means that a is equal to 26. And also c squared equals a squared minus b squared, so 100 equals 26 squared minus b squared, so b squared equals 26 squared minus 100, and if you work that out, you get b is equal to 24. So the equation is going to be x squared plus y squared equals 1. The a squared goes underneath the x squared because that's where the major axis is, so it's 26 squared and 24 squared. And one more question, which is even harder. What if the eccentricity is given as 5 over 13, and the value, and the minor axis endpoints are 0, 24, and 0, minus 24. So they're here and here. This is going to be wider, because that's if the minor axis is vertical, the major axis is going to be bigger. So it doesn't look like a lot of information here, but let's see what we can do. C over A is 5 over 13. That's given to us. A nice thing to do here is to square both sides. You'll see why in a second. And with this, we can calculate out C in terms of A. C squared is 25 over 169 A squared. That's going to be useful because B is known, and we also know that C squared equals A squared minus B squared. So I can say that 25 over 169 A squared is equal to A squared plus minus 24 squared. Add the 24 squared to both sides. Subtract 25 over 169 A squared to get 144 over 169 A squared. And if you multiply both sides by 169 over 144, you'll get that A squared is equal to 676, or A is equal to 26. So once again, the equation is going to be x squared plus y squared equals 1. A is 26, that's going to be 26 squared down there, and B is 24, that's going to be 24 squared there. Okay, pretty confusing, but that's the whole thing in 10 minutes.